physics that we're able to see with the radio world. And with optic, we're looking at hotter things, but not the hottest things. The hottest things come to us from X-ray. So what we're really probing is different energy events, since electrons and magnetic fields are happily creating all sorts of really cool radio astronomy stuff to look at, we're looking at physics of magnetic fields. And you can also do all sorts of cool measurements of the dust off of systems and how the light gets scattered as it comes through by looking at the polarimetry of it. I'm going to stop now. There's a lot. It's cool.
Magnetic fields.
Yes. And cool stuff. And
very, very cool stuff.
Yeah.
Like.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello, welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Julie Tomei, and I am joined by Dr. Elena Hyde. Hi, Elena.
Hello. A fancy meeting you here.
I know, it's the Julie and Elena show one more time. We are broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time. That is Tuesday morning at 1 a.m. Universal time. York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between 9 and 10 p.m. local Toronto time. Go to observatory.info.yorku.ca and follow the links for OPV, that's online public viewing, and join in the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have about our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory and Facebook at Alan I. Carswell OBS. All of our programs are free, but if you would like to make a donation, we will not say no. Head over to our website at observatory.info.yorku.ca. We will be monitoring the chat room for questions and to post content. And the current weather is, I don't know. I didn't look.
Ooh, it's bad. It's bad. It's cloudy and rainy, and we can't open the telescope. So, boo. That's all I have to say about that.
Yeah. It's not been pretty weather since. Well, Saturday was gorgeous.
Friday and Saturday both. And actually, Thursday wasn't too bad. Thursday, Friday, Saturday, and then back to rain.
The clouds came in and the rain. But you know what? At least it wasn't snow.
That is true.
We are headed in the right direction on that front.
This is, I believe, what they call lowered expectations in terms of the weather's bad. But hopefully it will pick up and we'll get clear skies again this week. Fingers crossed.
Crossing the fingers, definitely hoping for some clear weather in a couple of weeks. Let's say around the 15th. It would be great.
Yes, the 15th would be excellent. Lots of events happening on the 15th, everybody, all
Yes.
around that lunar eclipse, which I'm sure we'll talk about later.
We will. All right. So let's get started, shall we?
Oh yes, I see. I'm first, aren't I?
You are.
Let's do some this week in space and history. And I thought for a change, I would actually pick something that was in history, but not like an incredibly long time ago. So one of the things that's happened in the recent history is that we humans have actually gotten very, very good at finding other planets, planets around other stars other than our own. And of course, this was one of the first real puzzles of astronomy is, would there be planets around other stars? Why not? But we couldn't see them for the longest time. And so finding planets at all was a big, big chore. And once we got to the technology point where we're actually able to detect them, there's been a bit of a exoplanet explosion. So on May 2nd, 2016, there was a great article that came out for temperate Earth-sized planets transiting a nearby ultra-cool dwarf star. And I'm calling this out, it's just from 2016, but as of basically yesterday, the 1st of May, 2022, there are, as I'm looking at the list, 5,017 confirmed exoplanets in 3,694 different planetary systems, with 822 of those systems having more than one planet confirmed. And so this is really incredible. And it's something to I think, really enjoy, because the first evidence of an exoplanet was thought about all the way back in 1917. So this is our own century here, but we couldn't actually recognize it as scientifically with strong evidence until 2016 from that particular system. We had all kinds of people trying to get the first detection of an exoplanet. There was a possible candidate in 1988, but that candidate took until 2003 to finally get confirmed. And so people thought they saw a signal, but of course, these planets are so tiny compared to their stars, and those stars are so far away. The first confirmed detection wasn't until 1992, and that was Pulsar. And I remember when that came out. Well, okay, not when it came out, but 5 years later when I found out about it. I was super impressed. And this Pulsar doesn't have a fabulous name. It's PSR something B1257 or so. It's in the constellation Virgo. And a pulsar, of course, is a sorry, dry throat, dry air. That's all more. I guess the rain's good for something. But pulsars, as you may or may not know, they're actually traditionally thought to be sort of dead stars, either a neutron star or something like that. And this one we do think was a neutron star. So it's a remnant of what used to be a star on the main sequence. It evolves off the main sequence. It sort of sloughs off its outer layers. It's some sort of explosion, and you get a neutron star left over. And so this is a leftover of something that had already evolved outside of its life. So it's not a star in the traditional sense, certainly nothing on the main sequence. But because it puts off this pulse, it's a millisecond pulsar, it was actually very, very well known in time. And so this thing was blinking on a fraction of a second, and the pulsational period should be so reliable. And they found deviations. And that, of course, led to the planets being found around this pulsar. And so it was a case of our first chance at really, really good information from another star. And of course, having something that's timed down to a millisecond to base your measurements on really helped. So I believe it has something like 3 3 planets in the system. And of course, after that, people started finding more and more and more exoplanets around all kinds of different things. We have lots of different ways of finding exoplanets. We can, of course, look for the variations in the star's light. If the exoplanet goes across it and blocks the starlight, we'll see a dip. We can look at the spectra. We can look at the wobble of the star if it's a massive enough planet. And there's all these kinds of ways we can try to detect these little tiny things around these other stars, and they're just so it is really mind-boggling just how small of an angular separation they are on the sky, because even our closest star to Earth, we can't easily see the planets around that. That's Proxima Centauri, which it does have a planet, but was actually not found until very, very recently. So we have all these planets now, of course, discoveries of exoplanets kicking up. And initially, large planets were the easiest to find, so we found more large planets. And finding Earth-like planets was what everybody wanted, but of course Earth is a very small planet, all things considered, so finding things like Earth was incredibly difficult. So you had a lot of things like hot Jupiters and all that stuff. So that gets us finally to this 2016 article of this temperate Earth-sized planets, and this was a nearby ultra-cool dwarf star. And so this is something that's 2,700 Kelvin or so. This is a low mass star, and it had something like a sort of Earth-sized planet in a temperate, reasonable area going around it. So it was getting, shall we call habitable levels of light. And this dwarf type star is also called TRAPPIST 1, and it has the planets around it are listed in terms of A, B, C, D. So that's your usual sort of planet nomenclature, just in case. So I guess we would be Sol C, third planet from the sun, if you go by that nomenclature for our own. So what they found was using an infrared telescope, they're able to detect the signatures of planets going around this star, and then look at light curves. And so you can look at the light curves to try to measure properties. You can try to directly detect planets. It's really, really, really challenging. There's something called nulling interferometry that tries to block the light from the star, so you can see the really, really weak light coming off of the planets. But this kind of planet really caught my eye because temperate Earth-sized planets around ultra-cool stars or ultra-cool dwarf stars is actually something that the James Webb Space Telescope might be particularly well suited to find, because it's got, of course, infrared detectors on there, which will help to find the not huge amounts, but reasonable amounts of heat and light coming off of these little tiny Earth-sized or around Earth-sized planets. So it kind of means, what we saw before with Kepler, an explosion of exoplanets coming off. Maybe we'll now see that again with James Webb Space Telescope and lower mass planets. Because if we're right about how we think planets and stars form, there should be a lot more low mass things than high mass things, and there might be just a whole nother exoplanet explosion. So if there's 5,000 now, who knows what we're going to be looking at in a few years. And it sort of got really kicked off with these low mass planets back in May 2nd of 2016. So let me just see if I can call out to the original authors, Michael Gillen. So that's his just Gillen, Jahan, Lederer, Delraz, DeWitt, and Bordanov. So that was their 2016 paper, and I thought this would be a fun time to kind of talk about that, especially given what's currently going on with JWST putting out yet more tantalizing images. So check out those if you haven't seen them.
Awesome. Yeah, exoplanets are so interesting.
They really are. And it's just there's so many possibilities and there's so much out there that we can't see that should be there, but we can't prove it. And so it's kind of a little bit still in the same situation we found ourselves in 1912, which is, well, gosh, or 1917, I should say, the first evidence of an exoplanet. Well, it's probably there, but we can't prove it. And if we can't prove it, then we can't say it's really there, can we? Not as scientists.
I just, like, I spend a lot of time talking to grade sixes about space. For those who are listening from outside of Ontario, grade six is where we have a big astronomy unit in our curriculum. And it's interesting to tell them, like, we know about thousands and thousands of planets outside of our solar system. And when I was your age doing this unit, we didn't know about any. Like, if we knew about the planets in our own solar system, and we thought, yeah, there's probably other planets elsewhere in the universe.
Yeah, but we didn't
in the galaxy.
We didn't actually know. We didn't have it confirmed until 1992. So
yeah,
this is pretty darn recent. And
pretty recent.
And it's just, even in the last few years, we've found so much more about these planets, and especially the behavior of low mass planets or Earth-like planets in habitable zones, which means, just for anyone who hasn't heard the phrase before, that's kind of also called the Goldilocks zone, where if you put that planet around the star, it could have liquid water like Earth does. So it's a not too hot, not too cold spot.
Yeah. And like, even thinking of like number of exoplanets that we know, even when I was a student at York, the number was still really low because Kepler hadn't launched yet. One of my friends was actually working for John Caldwell in the summer, doing like preliminary work on the spot of sky that Kepler was going to look at.
Yes. Well, Kepler that is definitely worth like specifically giving credit to them, because if you look at the number of planets that we knew about, all the planets before Kepler, there was, of course, those planets going around the pulsar, and then a whole lot of massive Jupiter-sized or larger planets. And after Kepler, the distribution went the other way, and all of a sudden we could find the Earth-like planets. And it wasn't until, again, 2016 that we actually were able to find a planet around the literally closest star to our own sun. It's Proxima B it is the closest, and it took us until 2016 to be able to see its planet, or one of its planets. We don't know how many it has because we still can't detect it. Yeah. They really are that hard to find. So
yeah, well, for sure we're going to keep finding more and more, and people are going to probably find other methods as we move along as well. And looking forward to web discoveries of planets and many other things.
Yes, and imagine your favorite planetary system. So sci-fi authors, please take this off here and. But yes,
here's your writing prompt.
yes, writing prompt. All the planets.
3, 2, 1, go. All right, let's move on to our next item. This one's mine. We are looking at May 7th, 1992, and the launch of STS-49. This was the maiden flight of the space shuttle Endeavour. Its main mission was to capture Intelsat, I'm sorry, I'm having a hard time with English this evening, Intelsat 6, which was stranded in an unstable orbit since its launch back 2 years earlier in March of 1990. So they were going to do that during an EVA. It was equipped, the satellite was equipped with a new perigee kick motor and then released into orbit. And then the new motor fired and put the spacecraft into a geosynchronous orbit so that it could be useful and operational. The capture actually required 3 EVAs. The first one was the planned one, in which the astronauts were unable to attach the capture bar to the satellite from position on the Canadarm. The second one was unscheduled, an identical attempt the following day, and then they had a final unscheduled but successful hand capture. And that one was a spacewalk by 3 astronauts, and the orbiter was delicately maneuvered to within a few feet of the satellite so they could grab hold of it. An assembly of station by EVA methods, or ASEM structure, was erected in the cargo bay to serve as a platform to help in the hand capture and attachment of the capture bar. A planned EVA was also performed as part of that experiment to demonstrate and verify maintenance and assembly capabilities for Space Station Freedom. Space Station Freedom, you ask? It was supposed to be a space station that then didn't happen, and then the ISS happened.
It's a better name, I think.
Space Station Freedom or International
ISS?
Space Station? Yeah.
I don't know. So you don't really want everything just flying out into space every direction, right? So
you want things in space to be tethered. Yes.
I want my space station to be contained, vacuum sealed, all that good stuff.
Things are tethered and in their stowed properly. Yes. Experiments conducted during the mission included a commercial protein crystal growth experiment, ultraviolet plume imager, and the Air Force Maui Optical Station investigation. The mission was extended by 2 days in order to complete all the mission objectives. And many records were set during this flight. They included, as I mentioned, the first flight of the Space Shuttle Endeavour, the first and only EVA, including 3 astronauts, the second and fourth longest EVAs to date, the first shuttle mission to feature 4 EVAs, the second longest EVA time for a single shuttle mission, and the first shuttle mission requiring 3 rendezvous with an orbiting spacecraft, and the first to use the drogue chute during shuttle landing.
Well, it must have been a little softer with the chute, I would hope.
I imagine. What I find interesting about Endeavour is it's basically like the spare parts space shuttle.
Yeah. Yes, that's true.
So we looked at what we had around, and we just slapped together a space shuttle.
It did quite well for a very long time.
Absolutely.
As well, so.
Flew 25 missions, I believe, between 92 and 2011.
Yeah, that sounds right to me.
I know it's right. I was looking at it earlier today.
Okay, good. I'm going to believe you, but yes, it's good to know these things are researched.
Yeah, I just have to say it with more confidence. Yeah, it's interesting because I know certain things, for a while there, things were launched from it, and we all often talk about Hubble,
and the
missions.
Yeah.
But you kind of sometimes forget, oh yeah, the space shuttles were sent up there to fix other things that were going wrong, like this Intelsat satellite, which we talked about Intelsat in our last 3 shows together or something.
Yeah. Well, and it is interesting is at the moment, if you are going to launch something, you have to either have a way to prepare it or plan for it to become eventually unreachable, right? And if it's in orbit, there's an ongoing discussion about how we're going to deal with all the stuff that's up there already. And I think this is kind of part of a shift towards more and more of these smaller satellites that are meant to drop into the atmosphere and burn up when they're done, rather than needing to be repaired. Which is just a little bit of a shift in, I suppose, the ability to make these things very small, and also our inability to go up and repair them.
Every now and then I wonder about the satellite graveyard.
Yes. I
how
wondered
much stuff is there?
A lot of stuff. Well, and there are multiple debris clouds now. One more after the last explosion of that. Was it?
Yes.
Gosh, that was last year. Was it? They blew up the satellite up there.
Yeah.
Yeah. So there are debris clouds. There's a lot of stuff up there, and it's I'm actually interested to is there anyone studying space archaeology that would go up there and find these cool old satellites? And I don't know.
That's not what they mean when they say space archaeology these days.
No, you get different.
They mean archaeology from space.
Yeah.
What you're talking about is something completely different.
We'll have to come up with a new name for it.
Yeah.
I know galactic archaeology is totally different. So
yeah, that wouldn't quite work either. We'll have to think on that one. We'll have to noodle.
Planetary excavation? No, that's I don't know.
I don't know, but it would be interesting to have some sort of inventory.
Yeah, well, and at some point, if you've got room, we could put a little museum up and have everyone go visit. Be awesome.
Well, with all this space tourism.
I know, right? So one step after space tourism is space museum, and
yeah,
I mean,
what do you do when you go traveling? You go to museums, right? That's what I do.
Yeah, of course. I mean, of course they're gonna. So all I'm saying is that SpaceX should call us and you and.
All right.
All right, so we're starting a new space museum, and we'll put all of the cool stuff we find in orbit in there.
Sounds cool. That'll be our next career. Let's move on to our next item.
Yes, so I saw that you had the word freedom, and I was like, aha. Well, what do we know about launches of the U.S.? They love to call things freedom. So I actually found another one from a little bit earlier than the STS-49, the Endeavour. This is all the way back from May 5th, 1961, where they still love to name things freedom. And they had the Freedom 7. So on May 5th, 1961, Alan Shepard Jr. was launched into space aboard Freedom 7, the Freedom 7 space capsule. And he actually became the first American astronaut to travel into space as a result of this. So this was a successful naming of something freedom that did get launched. And this was, of course, in response to the Russians' successful cosmonaut Yuri Gagarin being the first person in space and the first to orbit the Earth. So it was a bit of a blow to the Americans. They were hoping to be the first, but they were not. So they wanted to go up and have their own successful orbit, and the Alan Shepard was the one who got to go. So this was a pretty awesome sort of day in history. It was a little bit of a kickoff to the space race because it was a response to what was going on from the Russians, and the flight was about 15 minutes long. So it's not anything compared to going up to the space station. You're not going to be able to spend very much time in the museum at 15 minutes of flight. But it was a big triumph because they were actually able to get someone into space successfully and bring them back. And it really established the U.S. space efforts. So this was after the Soviet has had quite a few victories. Of course, they had Sputnik 1 in 1957, and of course they had, as I mentioned before, Yuri Gagarin was the first in space, and it took a little while for the U.S. to catch up, but Shepard's suborbital flight gave everybody a little bit of a boost over there, and they continued to kind of go neck and neck and sort of follow along with what the Soviets were doing until the Apollo lunar program actually took a giant leap forward, and that was, of course, getting onto the moon. And just as a little note, Alan Shepard, he became the first American in space, and he actually did make it to the moon. He wasn't the first on the moon. He was the fifth, I believe. So he was actually going to be part of Apollo 14, the lunar landing mission. So he had a pretty good history in space, and it's a little bit of an interesting story because, of course, it's a very interesting time. The 1960s is there was, we're all in interesting times now, but it was certainly interesting times then as well. So Alan Shepard Jr. or Alan Bartlett Shepard Jr. He was a astronaut, an aviator, a test pilot. He did, of course, become the second person and first American to travel into space, and he got to go to the moon. So he had a pretty storied history and quite a few successes, but it was a little bit of a close call. So he was part of the astronaut program. He was part of the Navy. It used to be, I think, quite common for people to be in the military. And he was sort of informed about he would have a chance to be in the NASA mission, but he wasn't in, quite as good of, I guess, shape as the rest of the astronauts because he had some pretty apparently an intense competition. And what they're saying is that in order for him to get this mission to become the first in space, he actually had to quit smoking and adopt John Glenn's habit, who's another astronaut, of taking a morning jog. And so this was actually, the astronauts smoking was pretty common. So it used to be, people did not realize that this was a deficit to your, fitness level. But he was able to get himself ready and apparently was able to pass the physical eventually after quitting smoking. So don't smoke, kids. Astronauts say so. And he had a 15-minute flight, and so Gagarin, by comparison, he had a 108-minute orbital flight, and well, actually, Gagarin had strictly automatic, and Shepard had some control, but it was still largely automatic. It goes up, it comes down, and it was televised. So fortunately, it did go well, and it was launched atop a rocket that you might not have heard of. I don't think these were used terribly often afterwards. It was called a Redstone or a Mercury Redstone rocket. It was then evolved off into more powerful Atlas, the Atlas booster and the Atlas rocket. So it was kind of a precursor to the rockets that NASA would use later on, which is really quite cool. And after they splashed down in the Atlantic, it was apparently a very, very dramatic recovery because it wasn't particularly easy for them to get the Freedom 7 out of the ocean again. I don't know exactly what difficulties they had, but they had to use a helicopter retrieval system, and they have gone on record, and Shepard in particular particular was on record as saying something like, "I didn't feel like it was a success until they had recovered the capsule," which I take it to mean something like that was probably, I don't know, maybe lots of waves or something, and you know, a bit of drama. So he had to sort of get out of the hatch and you know, into the helicopter and sort of I don't know, something out of James Bond, maybe a little bit. So he did successfully do all of this, and it was a successful mission. And he then later on did get to go to the moon in one of the later missions, and he was scheduled to go on a Mercury Atlas mission, actually, a few years later. But it was June 12th, 1963, and this is actually a little crossover with James Webb, because Shepard, after having done this and gone to the moon, they were planning a Mercury Atlas 10 3-day mission that would be piloted by Shepard, but James E. Webb, the NASA administrator, who was named after, the telescope's named after him, that you all heard about, he said, the Mercury has accomplished its goals and no more missions will be flown, probably for safety reasons. And Shepard actually went and made a personal appeal to President Kennedy and did not get it. So unfortunately, the Mercury Atlas 10 mission was canceled, and he then got to go on to, I believe, a Gemini mission, but had some medical difficulties and various other things. So he did eventually get to the moon, and as fourth or fifth astronaut on the surface, and he had a long career after this, where he racked up the awards as you would expect. But it was of course all kicked off on May 5th, 1961. So almost this day in history, and lots of interesting drama around that whole Freedom 7 flight. So I recommend reading up on it, or at least trying to there are some images you can find of the helicopter trying to lift him out the door of the splashdown capsule. So very exciting.
Was Shepard the one who snuck the sandwich into space?
That is a good trivia question. I am not sure I've seen anything about a sandwich from Shepard. I think it was someone else, but that is entirely, I just don't know. So I suppose my sandwich knowledge is less good than my espresso knowledge.
Oh no, it's John Young. I'm getting my American astronauts confused. Sorry.
Well, he did get the first American flight, but I think in some ways he is a little bit overlooked because, of course, he wasn't the first human in space, and he wasn't the first, of the astronauts on the moon. So he sort of got a little bit of a side note in that sense.
Yeah, but it's like, I mean, I know his name, so like it's not like he's like forgotten in time. No. He's definitely he got a lot of press for the mission at the time as well. So he would have seen lots and lots of news articles if you'd been around in the 1960s.
And so when
it's like ask 100 people who the third guy on the Apollo 11 mission was.
Yes.
I mean,
exactly.
Black holes.
Yeah, well, for the
but I only remember because I knew someone else with the same name.
Black holes themselves, of course, are black. That no light is escaping.
Yeah, well, and it's there are always a case of people who get maybe less press than they deserve, people who get more.
This is true.
Try to balance it out a little bit. But it is quite interesting to note he's got, he did have the first, U.S. sort of space flight. So in that sense, it's good to remember him a little bit at least.
Absolutely.
He didn't have anything about a sandwich, but I do know that
no, that was, as I said, that was John Young.
He has a less glorious astronaut fun fact because he was the first, right? He was the first American sent into space, and they had not figured out spacesuits really, and they also hadn't figured out any way for bathrooms. So he had to, you can look this up, he had to wear what were called fecal containment systems for use during extracurricular activities.
Let's call a spade a spade.
Yeah. The early astronaut suits did have to wear diapers, and I believe that Alan Shepard on his first one, I'm not sure he even had the diaper. As I looked up his spacesuit, and I couldn't, it was kind of like you just go and hope for the best, and they clean it out when you get back, because he was only up for a few minutes. But
you know what's ridiculous is like, you show this stuff to any child, and their first question is, excuse me, how'd they go to the bathroom?
Yeah, and the answer is the first astronauts, they kind of just had to pee their pants.
Right?
And then,
how come a bunch of adults, how come a bunch of engineers didn't think, oh yes, we need to think about that?
Well, that is one of the things that's, it seems kind of amazing that rocket scientists could have forgotten about such basic human needs. Or like, maybe they just thought that because the astronaut was in such good shape, he could just like not go. But yeah, it has been remedied since then. You no longer have to wear urine collecting attire. So if you go into space, so good news for our future space museum, we can have bathrooms.
Hooray!
Typically to get the redshift of the object.
Anyways, that's for all the kids in the audience wondering about the pee.
Excellent. All right. So you're listening to York Universe, if you're just tuning in, broadcasting live from Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. You can head over to observatory.info.yorku.ca to join in the chat for questions, content. You can reach us on Twitter and Instagram at York Observatory. Tonight you are listening to Julie and Elena. We are talking about this week in history. As Paul would say, waxing somewhat eloquently on things of the past. So if you want to join in the chat, swing by the website and click on the OPV in the menu bar, and you can join there. All right, let us continue. Okay, I think I'm going to skip my next history thing if we're going to have time for our news and our reminders, but I don't want to skip your last history thing, Elena, because it's really cool.
Okay, so this one I got super distracted about because this is one of my favorite things to read about is really, really old observatories. And it all came about because a long time ago, this is where I'm going to ask everyone to please go on a journey with me back into history, way back to 1481. On the 3rd of May, 1481 was the death of Mehmed II, or Mehmed the Conqueror. This was a famous Ottoman sultan who ruled actually twice. He ruled from August of 1444 to September of 1446, and then again from 1451 to 1481. So I thought it was instantly caught by this because he's Mehmed II and he ruled twice, which is awesome. And this is the 1400s. So you're going way back in time, and this particular sultan had a lot of overlap with arts and sciences and astronomy. It was a little bit of context for everybody, because this is quite a long time ago. At the age of 21, he conquered Constantinople, which is
Istanbul today.
Yes, modern
Not
day.
Constantinople.
Not Istanbul.
Da,
Constantinople.
da.
Yes,
Sorry.
we will not sing the whole song, but modern day Istanbul was Constantinople. He conquered Constantinople or / Istanbul at the age of 21, which actually brought an end to what was the Byzantine Empire. And this is a really, I keep saying an interesting time in history, but this really, really was, because around that same time, in the, so I call it the early 1400s, the 1424 to 1429, in the Constantinople, I should say, they had recently constructed the Ulugh Beg Observatory in Samarkand. And this observatory was absolutely the place to be. It had amazing facilities, things that were matching the capability and the resolution of, for example, Tycho Brahe's observatory in Europe, if you've heard of that one. It was still a naked eye observatory, but it had so many highly detailed measurements and accurate astronomical catalogs. There was huge catalogs of stars with really accurate positions. There's books of what were called fixed stars that come out and had updated work that people had done before, like Ptolemy. There was a trigonometric table, sine and tangents, calculated out to 8 decimal places perfectly correctly, which is what you needed for these old astronomical measurements. And the observatory in this era was a real gem, a real gem. And so Mehmed II, or depending on how you want to say it, I think I'll call him Mehmed II rather than Mehmed the Conqueror, because this was a really interesting time, because he, in addition to encouraging the observatory and lots of other sciences and just astronomy in general, he was actually responsible for a lot of political and social reforms. And by the end of his reign, his rebuilding sort of program had actually kind of revitalized Constantinople. He's actually considered a hero in quite a few places. And if you go to Istanbul today, there's several districts and items named after him. There's the Fatih Sultan Mehmet Bridge, there's mosques, and there's a district all named after him. And he really was a champion for mathematics, astronomy, and theology, and invited a lot of Muslim scientists and astronomers. There's Ali Kushi, who was a pretty famous astronomer at the time, basically come in, do your science here. They had a university that they started. They built mosques. One of those is actually named after him as well. And they some really beautiful universities, basically, which lasted and kept their rank for about a century. With really, talk about, I suppose the Harvards of their day, if you want to call it that. Amazing place, and amazing person, not just, of course, as a, conquering and ruling, but also championing science in general. And it's absolutely amazing that it's sort of, I found this. If you don't read about anything else, make sure to read a little bit about some of the astronomical constructions that were done in his reign. Some of them still exist in Istanbul. And if you ever get a chance to go, I definitely advise looking them up. The Oleg Beg Observatory in Samarkand is still partially there. Apparently, the walls used to be lined with marble, but they are not quite anymore.
The marble may be gone, but the tiled entranceway, or I don't know. I looked at some pictures, and
yes,
it is gorgeous.
Yes, really,
gorgeous.
Really.
It is a work of art. So if you have any interest in like architecture, Islamic art,
or even just math and science in general, because these by eye observations were done incredibly precisely, due to the sort of devices that were built into this observatory, and it has what's called a quadrant principle device, and it's really something to behold. So even if you're just a math fan or a geometry fan or an art fan, it's all worth going for.
Apparently, we are starting a travel
blog. Yes,
travel agency or something of the sort.
So I'll just go ahead and say, I'll take this almost 3 of May to remember in 1481 the death of Mehmed II, or Mehmed the Conqueror, who, among other things, really did an amazing job with mathematics, astronomy, and theology in Constantinople, or modern-day Istanbul.
Awesome. All right, a couple of reminders, and then we'll have time for a news story. So, Teletube, Elena, what's happening this week?
Oh, excellent. So this week we will be having an in-person tour. So if you would like tickets, please go ahead and get your free Eventbrite tickets on our website, observatory.info.yorku.ca. And I'll just give a little call out as well. The other announcement I just have to make is that we are incredibly pleased to announce the very first astronomer in residence for the Killarney Parks Air Astronomer in Residence program with the observatory. So this is with the Alan I. Carswell Observatory. We are doing an astronomer in residence. Our very first astronomer is going up on May 9th. And I just want to say a huge congratulations to Blake Nuncarrow, RASC member and amateur astronomer, who will be going up as our first astronomer in residence. So you will be able to find out information from him, his blog, the photo archive, and if you are out camping in Killarney Provincial Park, you'll be able to stop by the observatory and see him live.
Woot woot.
Yay! So congratulations to Blake, and anyone else who's interested in applying. Actually, that's again our website, observatory.info.yorku.ca, and then just /AIR or AIR, or just click on Astronomer in Residence program.
Excellent. And I have a reminder. We mentioned it last week, but I want to mention it again. Space Place Canada has 2 events coming up in May. A warm-up event for the eclipse on May 15th with Sarah Mazuri talking about lunar exploration, and Elizabeth Howell talking about Canada-Army collaboration on the 19th. And Eventbrite links are up on the website, spaceplacecanada.ca. So head over there to get those things. And is the observatory doing any thing for the eclipse, Helena?
We are going to live stream it as much as we can.
Awesome. So here's hoping for that clear weather. Do you have a preference for our 2 news stories?
I would say mine's kind of silly, but so I'll just say really quick, it's almost May 5th. Or May 4th,
May 4th.
sorry. May 4th. So may the 4th be with you. If you want to know a little Star Wars crossover, published very, very recently, physicists are on the hunt for something called the Unruh effect, also known as quantum glow, which is theoretically the quantum phenomenon you would get if you tried to go in a hyperdrive equipped ship like Han Solo and Chewbacca. So if you want to find out about that, just look for Unruh effect.
Cool. They had an article about it on space.com, and I think I saw one over at Universe Today as well.
Yes, exactly. So may the 4th be with you, and then I think we'll have time for your article.
Awesome. So Titan looks like Earth, but why? So the surface of Saturn's moon Titan has some Earth-like features on it, and a new study explains why. So our listeners may know that there are lakes and rivers and canyons and sand dunes, but they're made of entirely different materials. Instead of water, it's liquid methane. Instead of sand, it's hydrocarbons. Because the sediments are theorized to be made of solid organic compounds, they should be far more fragile than silicate-based sediments on Earth. So nitrogen, wind, and liquid methane should wear the sediments down to a superfine dust, which wouldn't support these types of structures. A team led by Mathieu Lapotre, an assistant professor of geological sciences at Stanford University, has come up with a potential solution, and it's a combination of sintering, wind, and seasonal change. They studied a type of sediments called ooids, which can also be found on Earth and have a similar composition to Titan. Ooids are found in tropical waters and form very fine grains. And those grains simultaneously accrete material via chemical precipitation, but also erode in the sea. So they maintain a consistent size. And the team thinks that something like this is happening on Titan. So sintering involves neighboring grains fusing together into one piece, and that would be counterbalancing the abrasion from the winds transporting the grains. The team used Cassini mission atmospheric data to look at, weather patterns and looking at what sorts of things would be happening at the surface. And so they discovered that the winds were more common around the moon's equator, which created optimal conditions for the development of dunes. And then elsewhere, they think that lower winds allowed for coarser grains to form, and then in turn, sedimentary rock to form. Which would account for, your canyons and that sort of thing, because then the wind, the wind could erode that harder rock down to finer sediments, just like it happens on Earth. And Titan also has a seasonal liquid transport cycle, so then the moving of liquid methane would likely contribute to those processes as well.
That is awesome. And it's so similar yet so different to everything we know on Earth.
That's our show for this week.
Yeah. It's so, first of all, wow, this weird moon that has an atmosphere. Like, I remember it being like, wait, what do you mean this thing has an atmosphere, when it was first realized that it had an atmosphere?
And it's everywhere that you would think that there's water, it's not water, it's methane. And everywhere that you think that there would be dirt or soil, it's not soil, it's hydrocarbons, right? And there might be soil or rocky, like dusty thing somewhere, but they won't be at the surface because those are obviously hydrocarbons. And so it's such a totally different setup. Your pressure, your temperature, your very fundamental particles are behaving so differently from what we experience on Earth. It really is a totally alien ecosystem. And I love this because we were talking about exoplanets before. Yeah. And when you think about just the differences we've seen in our own solar system, how incredibly different Titan is because of its temperature, right? It's such a cold place, but who's to say that methane isn't doing something? I mean, it's obviously part of a liquid transport cycle, as you say. There's seasons, there's, maybe there's something in there. I can't wait till they get a sailboat.
Yeah, no, I can't wait till we have more missions there to see, like, to confirm these hypotheses. Like, oh, it's so amazing that it's like analogous, that these like completely chemically different things somehow end up being analogous.
Yeah, exactly. And like, what kind of crazy life forms might be on there? It's just so fun to think about.
Yes. The future is coming, my friends.
Yeah, some sort of super cold Titan methane worm. I can't wait.
That might be the stuff of nightmares.
Oh, I think it'd be awesome. I'm sure we'll be friends. Don't worry, Julie.
Okay, so long as it's not a giant worm that's gonna come and like.
Oh no, like Dune, but.
Sorry, that was my first thought.
Okay. Well, we'll find out with the sailboat and.
All right. Well, we are getting to the top of the hour. So thank you, everyone, for joining us this week. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, and alumni and friends of York University. Your hosts this evening have been Dr. Elena Hyde and myself, Julie Tomei. Stay tuned because it is Science Night in Canada. Coming up next is Quirks and Quarks, Western World and Science for the People. You can always connect with us online at York Observatory and at our website, observatory.info.yorku.ca. Thanks for tuning in. Clear skies and good night.
Good night, everyone.